Parkinson's disease is a disorder in the nervous system and the second most prevalent neurodegenerative disorder. It is caused by neurons in the brain gradually breaking down and dying, resulting in less dopamine production, which leads to progressive damage to regions of the brain that regulate movement.
So what is dopamine and how does its deficiency lead to all of this? Well, dopamine plays a vital role in reward and movement regulation in the brain, so its deficiency causes motor impairments.
High insulin and glucose levels lead to degeneration of nerve cells in the substantia nigra and the basal ganglia. These nerve cells are responsible for producing dopamine and releasing it to other neurons in the brain. When these cells degenerate, less dopamine is produced and released, which means other nerve cells in the brain do not receive dopamine in the first place to trigger their cell signaling pathways. Parkinson's is a matter of issues in the reception stage of cell signaling pathways.
SPNs are the spiny projection neurons rich in LRRK2 that release dopamine. LRRK2 is a protein that, if containing mutations, can cause motor impairments. SPNs send signals to other regions of the brain through a direct route promoting movement or an indirect route suppressing movement. The mutations in LRRK2 disrupt these signals, leading to Parkinson's disease.
Normally, the release of the neurotransmitter dopamine causes signaling in the postsynaptic neuron through D1 and D2 type dopamine receptors. This signals the G protein to activate the adenylate cyclase and produce CAMP. This activates pKa, also known as protein kinase A. The pKa triggers phosphorylation by DARPP32. This DARPP32 phosphorylates molecules called ERK1 or 2, mTORCI, and RPS6. These molecules leave and result in an action made by the body. In a faulty signaling pathway, the receptor will never receive the dopamine, which would not cause this cascade of events.
A decrease in dopamine levels can lead to a decrease in brain activity, causing symptoms like impaired movement, tremors, stiffness, bradykinesia or slow movement, rigid muscles, impaired posture and balance, loss of automatic movements, changes in speech, and changes in writing.
Currently, there is no cure to this disease, but medications like levodopa can significantly improve symptoms by allowing brain cells to change the medication into dopamine. Surgery may also regulate certain regions of the brain and improve symptoms. Scientists are currently looking into fetal dopamine cell transplantation, which is the implantation of fetal dopamine cells into the brain to make up for the lack of dopamine cells in a person with Parkinson's.